Good morning. I'm Padmapriya, Assistant Professor in Department of CSE in RMD Engineering College. Today we are going to see the topic depth first search under the subject data structures. Depth first search is a recursive algorithm to search all the vertices of a tree data structure or a graph. The depth first search starts with the initial node of a graph and goes deeper until we find the goal node or the node with no children. The depth first search traversal of a graph produces a spanning tree as the final result. Spanning tree is a graph without the loops. Stack data structure can be used to implement the data DFS algorithm. Now let us see the algorithm for DFS. Define a stack of size total number of vertices in the graph. Select any vertex as a starting point for the traversal. Visit that vertex and push it onto the stack. Visit any one of the non-visited unadjacent vertices of a vertex which is at the top of the stack and push it onto the stack. Now repeat step 3 until there are no new vertex to be visited from the vertex which is at the top of the stack. When there is no new vertex to visit, then use backtracking and pop one vertex from the stack. Repeat the steps 3, 4, 5 until the stack becomes empty. When the stack becomes empty, then produce the final spanning tree by removing the unused edges from the graph. Now let us consider the following example graph to perform the DFS traversal. Now select the vertex A as a starting point and visit them and push it onto the stack. Now from A, the adjacent vertex is going to be B and D. So any one vertex is going to be visited. Now let us consider B is going to be visited. So from A, visit the vertex B and push it onto the stack. Now B is on the top of the stack. Now for the top of the stack, B, which is the adjacent vertex, we are going to check. So for B, E and C. So A is already visited. So we are going to select C as the adjacent vertex of B and we are going to visit that vertex and push it onto the stack. Now for C, the adjacent vertexes are E and F. So we are going to select E as the adjacent vertex and we are going to visit the adjacent vertex E and push it onto the stack. Now for the top of the stack, E is present. Now for this, the adjacent vertex is going to be D and F. So now we are going to select F as a adjacent vertex and we are going to visit that vertex and push it onto the stack. Now for F, we are going to see what are the adjacent vertexes. So the adjacent vertexes are going to be G. C is already been visited. So now we are going to check. Now we are going to check from F the adjacent vertex G and we are going to visit and we are going to put it onto the stack. And from G, there is not going to be any new vertex. So we are going to do the backtracking. So we are going to do the backtracking and pop the G and come back to F. So from F, there are no unvisited vertex. So we are going to backtrack it and pop it from the stack. And from E, we are going to check there are going to be new vertex that is D, which is going to be visited and which is going to put on the stack. So from D, we are going to do again the backtracking and come back to E. There is no new vertex. So we are going to do the backtracking and come back to C and then come back to B and then come back to A. So likewise, we are going to come back to the starting vertex and all the vertices which is on the stack is going to be removed. Now, this is the final spanning tree from A to B, B to C, C to E, E to F, F to G, and backtracking coming back to F, then E, then going back to G and coming back to E, then C, B and A. Now this is the program for the depth first search. So for each and every vertex, we are going to visit. So once it has been visited, it is going to be put into the stack. So true. So for each and every vertex, we are going to check the child. So W is the child and V is the root node. So if the child is not going to be visited, it is going to be repeated. The depth first search is going to be repeated again for this child. If it has been visited, it is going to be end over there. This is the depth first search traversal program. Thank you.